Hello. This is the second of 2 classes on troubleshooting. Troubleshooting number 2 of 2. We will go over learning objectives, why do you need it, exercises, learning verification, and summary. Learning objectives. What steps would you take if a computer would not power on? What things would you check if the page cannot be displayed? What things would you check if the internet is slow for one user? What things would you check if the internet is slow for everyone? How does encryption affect MTU? How can QoS fix congestion? Why do you need it? Well, everyone appreciates troubleshooting, just like everyone hates Chris. Now, exercise number 1, troubleshooting process. What is your troubleshooting process? Does your troubleshooting process depend on what specifically you are troubleshooting? Now, this is meant to be more of a thought exercise where you would think about what your particular troubleshooting process is. You know. Now, for myself, I choose to do whatever gets the job done at a specific time, but usually I tend to try to discern what the client is trying to do and then work backwards from that point to help them resolve their issue. Because a lot of times there's often an issue in even properly communicating what their actual problem is. Now, does your troubleshooting process depend on what specifically you are troubleshooting? That's another thing to think about. In my case, I would say not really. I try to work through problems step by step. The steps may change by technology, but the intent is still to look at the problem in a step-by-step manner. For example, if I was troubleshooting putting on my clothes, I would probably want to make sure that I put on my pants before I put on my shoes, only because if I tried it the opposite direction, my feet are large enough that if I put my shoes on first, I would have great difficulty in putting on my pants. You know what I'm saying? Now, exercise number 2, an example troubleshooting process. This question asks, what is the 10-step troubleshooting process? Now, this example troubleshooting process actually refers to something that is called the universal troubleshooting process. This process has 10 steps. You can Google it. It's called the universal troubleshooting process. And step 1, believe it or not, says you need to prepare mentally. Prepare mentally means get your mind set that I can do this. You need to have the confidence that you will be able to troubleshoot the problem. Step number 2 is make a damage control plan. Think of this as, you need a plan for how you're going to communicate to the user community while you're working on resolving this issue. Because a lot of times when there's major outages, the customers are going to be obviously, they're going to be bothered if, say, there's an internet outage and you're some major internet provider, right? But they're going to be even more upset if you don't have some type of communications going out to let them know, hey, we're aware of the issue and we're working to resolve it. Versus if you don't do that and try to, have it communicated in a way that, the client can understand so that, you can do that damage control, because you want to try to, if possible, while working on troubleshooting this issue, you also want a plan where you can try to prevent this issue from spreading elsewhere. But really, this is more so dealing with how are you setting this customer's expectations. Now, number 3 is get a symptom description, because this is important. As I revealed earlier in my method, I like to try to verify with the client exactly what they're trying to do. Because if you don't get accurately what the problem is, if you can't accurately define the problem, you will not be able to accurately fix the problem. Now, the next step in this universal troubleshooting process is reproducing the symptom. Because if you can get that problematic behavior to be reproduced, then there's a chance that you'll be able to resolve it. Now, step 5 is doing the appropriate corrective maintenance. Now, for example, there is a chance that there may be some basic corrective maintenance that you always apply to the systems. Say you make sure their patches are up to date, that their antivirus is up to date, that they have the correct IP configurations, that they've been rebooted sometime within the last month or so. There may be some basic corrective maintenance that you can just attempt right away. And often, sometimes, just doing this basic corrective maintenance may even resolve the problem. Like, for example, there's a web browser issue to say, okay, clear your cache, delete your cookies, reset your settings, or whatever you may do, And a lot of times those basic remedial steps can often resolve a bunch of issues just because there is some corruption in the application of the configuration. And doing this basic corrective maintenance can flush that out. Now, if the basic corrective maintenance does not flush out the issue, now you need to try to see if you can narrow down where the problem is. You want to try doing particular tests to validate particular things. For example, when we were looking at the example of in the prior class about troubleshooting a website issue, you say, okay, let me check if there's a DNS problem. Let me check if the trace route looks okay. Let me check if the IP address is correct. Here, you're just trying to narrow down exactly what the problem is. Because if you can narrow down that problem space, then there's less things for you to try to work on. Now, if you sufficiently try to narrow down the problem, you can then attempt to repair or replace the defective component. Say, for example, if there's an issue where you find out your issue with accessing this website is because there's issues with this particular DNS server that we administer. And then you can say, okay, are we able to repair this issue with the DNS server? Or are we able to replace it by pointing the client to another DNS server that's not defective? So you will try to do an appropriate measure. Then in the next step, you will test. Because what's the point of making a fix if you don't validate that it works? You test and validate that the fix worked and that you fixed the issue for the client. Great. If so, wonderful. Now, step 9 is take pride. That is, you've got to give yourself a pat on the back for fixing this problem. Some of us have issues with that. We try to be humble, and we don't want to get big heads about anything. But you do need to be mentally prepared that, hey, and be confident that if you can work on this issue, and there's a reward at the end where you take pride in that you solved this problem, that before you had encountered it, you didn't know how you were going to solve it. So take a little pride in that you exercised your troubleshooting skills and you reached a positive result. Now, step 10 is important. You want to prevent future occurrence of this problem, if at all possible. And you want to make sure you document what actually happened and what it took to actually fix this issue. Because it may be a case of, okay, we need to schedule a maintenance on these DNS servers because the actual issue that broke the DNS server was maybe some disk filled up because you weren't doing appropriate maintenance to clear out some caches or something didn't get flushed, or some logs piled up that didn't get shipped correctly. Or maybe the issue was, oh, the logs went to another log server that was down and the DNS server was just holding them locally until it never had a chance to flush because the log server got hung up. Whatever it is, once you found that root cause and you repaired or replaced that defective component, you need to actually try to put in this long-term fix to try to prevent that problem from occurring again. Because nothing makes the job more boring than repeatedly fixing the same old stuff. I mean, you don't want to do that. You want to find fresh, new, and exciting issues to repair, don't you? Now, network problem isolation. Because we need to be able to narrow down what the problem is, right? So what are some common problem isolation methods for networks? Now here are some. Top down, which we explored in the prior lesson. Then there's bottom up. Then there's divide and conquer. There's follow the path. There's compare configurations. We sort of looked at this one. Swap components. And shoot from the hip. I'll explain each one. Top down is you starting at the application layer and work your way back down to whether or not the cables are plugged in and equipment's powered on. We went through this on the prior troubleshooting class. Bottom up starts at make sure the cables are plugged in, the system's powered on, everything's connected correctly, and then work your way all the way up until you get to the point of looking at the application. Divide and conquer is starting somewhere in the middle, such as does the system have an appropriate IP address? And then working your way from there to try to attempt to narrow down this problem. You can follow the path. You want to trace the path the traffic is taking and look for any hiccups. You can compare configurations. You can compare a known good configuration to the current configuration. Make sure there haven't been any, changes to the configuration or unapproved changes to the configuration. A good thing you can set up in your environment is some sort of logging for changes to, critical infrastructure. You want to make sure you have some logging set up so you can be notified when changes occur. And if it's a legitimate change, there's no big deal if you're notified. But hey, if it was an unauthorized change, it was nice that you got notified, because those can tend to lead to, not necessarily they can lead to outages, but a lot of outages are actually caused by human error. So that's just one of those things you have to deal with. Now, swap components. And in this case, you don't know what's wrong. You think, okay, maybe it's the power supply or maybe it's the power cable. Okay, I don't know. Let me change the power cable and see if the problem goes away. Okay, it did. Okay, let me change the power supply and see if the problem goes away. You just change parts and attempt to locate the defective part. Oh, maybe it's this capacitor here. Okay, I can't actually change this capacitor, but I can actually change out the whole motherboard. Oh, great. So you could maybe possibly change out the whole motherboard, for example. Now, then there's shoot from the hip. For a lot of network engineers, they won't admit it, but this is probably their favorite troubleshooting method, is shooting from the hip. And they will take a guess based on experience, intuition, or a hunch at what the actual cause of the problem is. And fortunately or not, in some cases it can be very successful, in some cases it can't be. But the thing to keep in mind is, when you're attempting to troubleshoot and isolate a problem, your guess could be wrong. And you may go down a line of investigation because you made an initial guess, and now you must attempt to prove, you're trying to approve or disprove that guess before you fail, and then go and try another method. So make sure that whatever method you choose, you're trying to use as much evidence as possible as you refine your troubleshooting based on the evidence that is returned. That way you will eventually get closer to what the actual root cause is. So that's just something to be careful of. Now, knowing normal. This is another thought exercise. Does it help to know how the technology works? Yes, of course it would help, but failing that, at least have an ordered method of troubleshooting, as we just went through when we looked at that universal troubleshooting process. Because in that process, for example, it didn't actually mention any specific technologies. It just had an ordered methodology that could be generally applied to troubleshooting for all sorts of cases. So if you have an ordered method of troubleshooting, you're very likely to be able to resolve an issue even if you don't know exactly how it works, because you'll be able to ask the appropriate questions of the subject matter expert for it. So you can sometimes help a subject matter expert resolve a problem with a technology that you are not expert in, because you will use sound troubleshooting principles. So just keep that in mind. Now, exercise 5, environmental specific exceptions. This is another thought exercise. Does the environment have any exceptions to how the technology would normally work? For example, do you have strict change control for your website that keeps things in great working order, except when the CEO, John Doe Sr., brings John Doe Jr. in to work as an intern web developer? Do all the controls get thrown out the window and you're constantly putting out fires as the website keeps going down during the summer? Don't worry. John Doe Jr. will be in charge of the web team next summer as soon as he completes high school. So you can look forward to that. But there may be some environmental specific exceptions. Now, this exception in this case was, was a person. But there may be exceptions to how the technology would even normally work in your environment. Say, for instance, in most environments, a firewall is used for purposes of, allowing specific applications or specific types of traffic or whatever to actually function and work on the network. But what if in some other environment, they're not really using it for that purposes, they're just using it more as of a network translation device or some sort of as a proxy device for web access or whatever. But they're not actually using it for any sort of other types of access controls. Even though the device may be capable, it may not be used for that purpose in that particular environment. So you think, oh, I normally use a firewall for this, but in this environment, they're only using it for their web proxy. Just an example. You may run into these things. So don't just assume that every time you see a hammer is necessarily being used as a hammer. It could be being used as a screwdriver, and you could be thrown off a little bit. Just keep that in mind. Now, exercise number 6. Understand the normal process. How do computers get an IP address? I just plugged the computer to the network. How do I get an IP address? And for this question, we're going to assume that security is not an issue. Now, if you've been paying attention in prior classes, you will know the answer to this question. Of course, what should happen is the computer should go through the DORA process, where it does the discover, offer, request, acknowledgement. If you're not familiar with this, you want to go back and review the class on DHCP. Exercise number 7. Understand the normal process. How does my computer know it has internet access? What does it really mean when that network status indicator says internet access? This is a good question because some people, you may not know, what does it really mean when it says I have internet access? Well, per Microsoft, it means that 2 checks have passed when a system changed networks. 1, the system can successfully make a DNS request for www.msftncsi.com, and 2, the system can retrieve http://www.msftncsi.com/ncsi.txt. Please note, this check can be disabled and the icon will not work as expected. So if you want to be mischievous and prank your friends, I don't know why you'd want to do this, but just know the icon could be disabled in a certain way. Well, the icon not disabled, but the check could be disabled. And then the icon won't work as expected because it will say you don't have internet access and you'll still be able to get on the internet. So keep this in mind. Don't rely upon that icon as an indicator because it's only making these specific checks. And I would think being able to get on the internet is quite different from being able to just connect to some Microsoft server or whatever. Now, exercise number 8. Understand the normal process. How does a web page get to a computer? Okay, for this case, we're assuming I have a valid internet connection. I just typed http://portquiz.net into my web browser. What happens to get portquiz.net to my computer? For this question, we're going to assume that security is not an issue and everything works. Okay, so what actually happens is this. The client will send a DNS forward query for portquiz.net. The DNS server will return a record for portquiz.net. The client will send a TCP send to portquiz.net server. The portquiz.net server will send a TCP send ACK. The client will send a TCP ACK to the portquiz.net server. The client will send an HTTP GET request for content from the portquiz.net server. The portquiz.net server sends content to the client. The client downloads the content and displays it in the web browser. That's what's happened in a normal process to get a web page to a computer. Now you can see in this example, several technologies we've covered are discussed here because we see DNS being involved. We also see the TCP handshake being involved. And please note, if the TCP handshake does not succeed, the client's never going to ask for the web page. And then even if the client successfully asks for the web page, it still has to download the content and display in the web browser. So if there's an issue in the web browser itself, it could cause you to fail to display the web page even though everything else is actually working. I mean, stuff happens, you know. And if you did face this case where it seemed like everything should be working, but you may have web browser issue, then you know what? There was that troubleshooting tip we tried before where you could say, let's try to swap components. Let's swap out the web browser to a different web browser and see if we can get this web page to load. And if so, then we know the problems related to that web browser. Okay, exercise 9. Understand the normal process. What does it take for me to receive an email? Now, I have a valid network connection. I have a valid connection to the email server in Outlook. I received an email from an internet user at gmail.com. What happens to get the email from gmail.com to my mailbox at hotmail.com? Wow, hotmail.com, that's awesome. Now, what happens to get that email from gmail.com to my hotmail.com mailbox? Well, we will see. The Gmail server will query DNS for the MX record for hotmail.com. The DNS server will return an MX record for hotmail.com. The Gmail server queries DNS for the A record for the return MX record. The DNS server returns an A record for the MX records. The Gmail server will send a TCP send to the MX server IP address. The MX server sends a TCP send ACK to the Gmail server. The Gmail server sends TCP ACK to the MX server. The Gmail server sends EHLO to the MX server. The MX server responds to the Gmail server. Now that the connection is established, the Gmail server sends the email to the mail server. As you can see, this is an interesting process, but it uses DNS, which we're familiar with, and it also uses the TCP handshake. This EHLO is actually specific to SMTP syntax, but let's continue. Now, after the mail has been placed in your mailbox, you'd make an HTTP connection to your mail provider. Hotmail is usually accessed via a web browser to retrieve the email. Of course, you can also use a POP or IMAP connection as well. Notice that no matter what method you're utilizing, a TCP-based application will first query DNS, then start with the sequence of send, ACK, and ACK, and after the connection is established, initiate the protocol of choice. As noted here, you did your DNS, and then you did your TCP handshake, and then you started initiating the protocol-specific connection. This one's for SMTP. Also, if you look here, we had the same case. We did DNS, we did the TCP handshake, and then we requested this HTTP application from this server here. So you can see that TCP-based applications will do this same basic thing over and over and over again. DNS has to work, the handshake has to work, and then the application has to work. Now, how can encryption affect MTU? If you set up an encrypted tunnel, how does that affect your MTU? Now, it's important to know that encryption uses up additional overhead such that there is less space left over for sending your data without hitting the MTU limit. Once the packet exceeds the MTU, you run into fragmentation problems. In some cases, the communication may fail entirely or be very sporadic. Think of it as you have a box to hold your data. When you encrypt the data, you're adding more padding, so there's even less space left inside the box for other stuff. Learning verification. What steps would you take if a computer would not power on? What things would you check if the page cannot be displayed? What things would you check if the internet is slow for one user? What things would you check if the internet is slow for everyone? How does encryption affect MTU? How can QoS fix congestion? If a computer would not power on, make sure that it has power. Is there a power outage? I know this seems, duh, but still, if the page cannot be displayed, by now you know to check DNS. You know to also check if the correct Uniform Resource Locator URL has been entered. If the internet is slow for one user, you know to check settings specific to the local computer, and you can attempt to isolate if the problem is in the user or the computer. If the internet is slow for everyone, then you can suspect that there is a high level problem involving maybe DNS, routing, or any network dependent services specific to your implementation. Now, of course, there could be actual issues at your internet service provider. It may be worth giving them a call if the internet is suddenly slow for everyone and you haven't made any changes. Now, encryption will reduce your maximum transmission unit. Adjust accordingly. Now, encryption itself does not actually reduce the MTU, but it reduces what you can send within before you hit that MTU limit, because this encryption uses up additional space within the box. So maybe the MTU itself isn't being reduced, but the amount of data that you can send while maintaining encryption actually would require a reduced MTU. So just adjust accordingly. Quality of service, QoS, cannot fix congestion. It can only try to cope with congestion. There are two things that can fix congestion. You use less bandwidth or obtain more bandwidth. That's it. As I said before, QoS treats the issue where all the lanes on the highway are full. So what do? You have another lane to say this is the express lane, and we'll let people go faster over here in the express lane. Priority traffic goes over here. Fire truck, ambulance, police cars, emergency traffic goes over here in this lane. So quality of service usually means actually that a select few, it has to be a select few, because if everyone gets it, then it does you no good. A select few are getting preferred treatment. That's what QoS really means. Everyone else is still suffering. So you got to decide who you can't allow to suffer. And that may be say, hey, I can't have my voice traffic suffering, because if the voice traffic delayed, then the phone call is just going to be horrible. So you're going to make these decisions of what's going to get that priority lane and what's going to suffer with the masses. So, and people can make careers out of only working in quality of service. That's how important it is. Now, so as I said, there are two things that can fix congestion, that can truly fix it. You either use less bandwidth or you obtain more bandwidth. That's the only thing that's going to really fix it. Now, it's just like, you're treating the problem, but you're not fixing the problem. Now, don't panic. Don't panic when troubleshooting, because you got to maintain your wits about yourself. Like when we looked at that universal troubleshooting process, that process, the first step said to prepare mentally. So there is no need to panic when you encounter a problem you haven't seen before. In fact, when I encounter a problem I haven't seen before, I get excited, because it's an opportunity to learn. It's an opportunity to learn something different, something I haven't seen before, or maybe it's a problem I've seen before, but I have not seen it expressed in this way. So it's always looked at as an opportunity to say, oh, this is fun. Let me see what's going on here. Let me see if I can figure this out, and just take a troubleshooting method and narrow down what the problem may be until I say, oh, this must be it. Let's see if we can resolve it. And when you resolve it, you feel great. You pat yourself on the back. So just don't panic. Now, there is no shame in making sure that the system is powered on, cables are connected, etc. There's no shame in doing that. And if you want to make that part of your basic troubleshooting, feel free to do so. I mean, there's no shame in making sure that, hey, has the system been rebooted recently, especially with Windows-based system for whatever reason. They've been getting better about that over the years, but it's always something to check. Now, you don't have to know how it works in order to fix it, but knowing more about how it works will help you ask the right questions to get the problem solved faster. Troubleshooting network issues is easiest if you have an error condition to solve. A source, a destination, a traffic generator, and a traffic monitor. Now, because you need an error condition that you're trying to solve, obviously, because if there's not an error you're trying to solve, then what are you even troubleshooting? There must be a problem. So now, by source and destination, networkers usually are referring to the source IP address and a destination IP address. By traffic generator, they usually refer to someone at the source side who can initiate that communication session. And by traffic monitor, they mean some of the network staff is set up where they can actually monitor the traffic as it's being generated to see what actually happens. And the best way to troubleshoot is live. If you can do live troubleshooting of a network issue, that is awesome. Sometimes you don't have that privilege, but if you can do it, it is fun, it's awesome, it's a blast. Now, knowing whether or not the TCP handshake successfully completes can resolve a bunch of network issues. So, if sometimes it's even a common interview question, they'll ask people, say, what's the TCP handshake? And you're like, what do you mean? But hey, you don't have that problem. If you've taken this class, you can go back and review the Transmission Control Protocol class. I do cover the TCP handshake, and you want to make sure it successfully completes, because you need to know what's happening when it sends that synchronized, and when it sends that synchronized acknowledgement, and when it sends that acknowledgement. What's really going on there within that handshake? And what happens immediately after that handshake? That's important to review. Now, learn more about TCP. It's used by most applications. So you want to know, how does TCP handle congestion? What is windowing in TCP? Really get into understanding that maximum segment size that I tried to go over a little bit with you. Understand how their incrementing sequence aligns with the amount of data that is being transmitted. Try to think of handy ways where you can analyze TCP sessions. Try to think of handy ways to try to analyze if there's issues with bandwidth. Try to be able to do calculations of what's the rate of data transmission. Just learn more about TCP. It's used by most applications, so if you learn more about TCP, it will be very helpful to you in your career, especially with so many applications being web-based. Now also, learn more about DNS. It's a linchpin service for the internet. Just a while ago we had some DNS provider, they experienced an issue. Some may call it some sort of attack, but I'll say they experienced an event, and because of that, there were many web properties that suffered as a result just because DNS had problems. So just make sure, that learn more about DNS, learn more about TCP. It can only help you in your career. Now, also, sometimes a good solution takes time. So you can't be afraid to change one variable at a time until the problem is solved. Because think about it, if you change multiple variables at once, you won't know what fixed the problem. So sometimes a good solution takes time, especially when sometimes these variables you may be modifying one at a time may not even be properly documented. So you may not even be entirely sure what the effect of this modification may be. But if you can make a change, hopefully it's a reversible change, in isolation, you'll be able to determine whether or not that change had the intended effect or not. Of course, if it does not, please revert to setting and try something else. Now, we're close to finishing. We're on the next to last slide. Now, it's important here. It says, be confident. I cannot reiterate this enough. Just be confident in troubleshooting. I know this video's a bit longer than the average video in this series. For that, I apologize. But I do not apologize for making sure that you are confident when you go out there to troubleshoot these network issues. Because you will find some issues you haven't seen before that will not have been covered in this class. This class is only about the basics. But most problems are solved the same way. You confirm the error, you reproduce the error, you isolate the root cause of the error, you take corrective action, you validate the problem's resolved. If not, you go back to step one. Confirm the error again. Now, once you fixed it, celebrate. One thing I didn't put on here, make sure you document. I did include it in the prior troubleshooting class, but I'm just reiterating it here. Document, document, document. You want to make sure you document this issue. And also, if you can take measures to keep this problem from happening again in the future, please do so. Please share information with your coworkers so that they can also be more effective troubleshooters. You know, don't worry about trying to maintain job security, because if you get to a point where you think you're irreplaceable, you know, now I'm getting into career advice, but if you get to a point where you think you're irreplaceable, you're actually hurting yourself, because what if the company thinks you're irreplaceable in that position, and now they're afraid to promote you? They're afraid to promote you because you've made yourself an essential cog in the wheel. You don't want to be in that position, do you? Now, also, it's just great to share information, because that's what networking is really about. It's about sharing information. So share the wealth. Now, final summary pages. Now, in some cases, if it takes too long to troubleshoot, it is simpler to take corrective action first and then troubleshoot. Example, reboot the system. It may fix it. In some cases, a workstation having a bunch of issues, you can't figure it out. Everybody else is working just fine. Just this one. All the other settings look correct, but just this workstation looks bugged. Just reimage the thing. It may fix it. Give them a different system and see if the issue goes away. Reinstall the application, reset browser settings, etc. You know, just try to take some simple corrective action. It may actually resolve the issue. And yet again, I must say, be confident you can do it. All right. Thank you very much for your patience. I know this class was a bit long. Thank you very much for this class on troubleshooting, number 2 of 2. Just thank you very much. Have a great day.